Silviculture and harvesting are forest management tools designed to improve tree growth, improve residual tree quality, and manage regeneration. But too often, harvesting decisions don't follow the science of silviculture. Instead, harvesting is often based on poor understanding of forest growth and development. In these cases, future options for sustainable forestry are lost. A common problem is selective harvests, which are not the same as selection. Selective harvests take the best and leave the rest. Let's look at an example of a selective harvest and then discuss the repercussions of poor forest management. This graph represents a typical Pennsylvania even-aged mixed-species hardwood stand. Tree diameters are shown on the x-axis and tree numbers on the y-axis. The blue line represents the sum of the three species that dominate the stand: sugar maple, red maple, and black cherry. In this example of a selective harvest, the dotted line represents the decision to cut trees larger than 14 inches. What happens? All the trees to the right of the line are cut, removing nearly all the black cherry. Only some of the smaller trees remain, and because black cherry trees are shade intolerant, these remaining trees are likely to have poorer crowns. Also, half the red maples are taken, again only retaining the smaller trees. Sugar maple is generally untouched. Only some of the biggest trees are cut. The selective cut leaves poor quality residual trees and seed sources are lost. The seed source for cherry is gone, and the red maple seed source is greatly reduced because the diameter limit selected focused the cut on larger trees. This type of select cut is also known as diameter limit cutting or high grading. It is a detrimental practice that threatens forest sustainability. This is a typical hardwood stand with trees of various diameters. Some of the larger trees have diameters large enough to harvest as saw timber, which means they have a diameter of at least 12 inches, measured 4.5 feet above the ground. At this size, they have the potential to yield some high-value lumber, which trees are likely to be cut. If the cutting decisions are merely opportunistic in nature and focused on short-term economic criteria, the X-marked trees are likely to be cut. This simulated cutting would remove the oak and the smaller white ash and cherry. It leaves behind beech and red maple. You might wonder why this matters. First, the biggest trees in an even-age forest were growing at a faster rate in both diameter and volume, and represent the most valuable species in today's timber market. The smaller trees, beech and red maple, were growing at a slower rate and represent the lesser value species in today's market. Thinking about this in terms of interest paid by a bank on deposits, the cut took the trees growing at the best interest rate in return to the future, and left the trees paying less interest return in the future. A high-graded stand or select cut stand is often very obvious. The spacing between trees is quite variable. In some places, too many trees were cut, and in other places, almost nothing is cut. There is seldom any consideration for regeneration, and plants that compete with regeneration, if there is any, are common. Prior to the cut, the residual trees were often in intermediate or suppressed crown positions. Due to increased light on their stems, buds along the stem may develop into epicormic branches. This degrades the future log potential. Some trees, lacking the support of adjacent crowns, bow over when opened up. The quality of most trees will not improve. Sometimes repeated high grading picks the stand apart, yet it still appears okay. While there may be trees of many different diameter classes, the species composition may be less than desirable. The quality of larger trees is likely low, and the options for management are low. In this stand, nearly every tree is an American beech. This stand is now dominated by one species, and a higher percentage of low-value trees remain. The negative consequences of high grading are numerous. All of them reduce current and future options for managing a forest sustainably. It may take many years to overcome. The consequences include diminished species diversity, reduced food sources for wildlife, increased risk of disease and insect outbreaks, and risks of storm damage. Decreased tree value, volume, stocking, and quality, slower tree growth per acre, an extended time to the next harvest of equal volume, and constrained future management options. Silviculture is about managing the residual trees that meet acceptable growing stock criteria. Silviculture also considers establishing forest regeneration. The management examples we have seen hinder the development of acceptable growing stock and regeneration.